Hey guys, how's it going? I hope everyone's doing all right. And today we are going to be covering raycasting. So, very fun topic, right? I'm going to show some of the changes that I've made to the code since last week. I've actually made quite a few changes. So it's looking pretty good. We're sort of getting closer to an actual Minecraft game, but there's one specific change that I want to start making, which is going towards this thing called approaching zero driver overhead, or ASDO. And this is a very important topic for modern OpenGL. And this is sort of the same approach that graphics APIs like Vulkan take. So this should speed things up quite significantly. So I'm really excited to see how this works out. And it should also reduce memory usage, because that's one thing that I've been trying to do with the way that chunks work right now. But yeah. Anyways, though, I do want to take a look at some of the changes I've made. I've refactored this code quite a bit. I'm pretty happy with the state it's in right now. So we have a very clear sort of application state and everything, right? The main file is nice and small, which is the way I like it. We initialize, we run, and then we free, which is how it should be. And then if we look into the applications initialization method, it's very clear what's going on here too. So we initialize the window. Then we get the window, which is just a singleton, and it's just defined up here somewhere. Or actually, it's defined inside the application's actual header file, because anyone can get it. And how's it going, Langors? I hope you're doing all right. So sort of do that, and then we get the window. We initialize all the other subsystems. So once again, it's all just very straightforward, which is the way I like it. It should be this way. And these do anything that they need to do. I've also added a key bindings. And if we take a look at key bindings, it basically just has a way that I can sort of load up key bindings. And I want to load this from a configuration file. That way in the future, we can map everything, and then the user can just set up whatever way they want. So we just have like different things for like locking the cursor, show hide debug stats, exiting the application, that type of stuff. Then if we go through the rest of this, it just does the same stuff that you would always do, right? We just set up the game loop. I want to get rid of this render clear color. This shouldn't be in here, but for now it is. We get delta time, and then we just update the world, and then swap buffers and pull input. So nothing special there at all, right? And then free just sort of deinitializes all of the subsystems, which is what it should be doing. So I really like the way that this entry point works and everything, and I feel like this is pretty clean. It just works. World, I've kind of cut down on a lot of stuff. It's still a little bit cluttered, and I do want to fix that eventually. But I have removed a lot from the update method and everything, so it looks a little bit better. Basically, we set up all the entities. I feel like this should go somewhere else, but I'm having trouble thinking of where to put entity setup and everything, right? Because it's like, do I put this in the world? Because technically the world is in charge of setting this stuff up, or do I put it somewhere else? But I don't know. I'll figure that out later. Set up the player, and then I set up some random controller. And then if I go down here, we have the free method, which just frees all the chunks, and it frees the registry and everything. And then inside the update method. So I've really sort of tried to cut this down specifically because I didn't like how big it was. So we just update all the systems, right? We update our key handler, our physics, our character system, our player controller, and our transform system. I just reset the debug statistics so that I can get that appropriately for the next frame and everything. And then I have this ticks thing. I might remove this in the future too. I only update the frame time every 10 ticks, which is just every 10 frames, because it's a little bit better. And yeah, I did start early today, Langors. I think I'm going to start a little bit earlier on Saturdays from now on, just because it gives me more time later in the day, and I'm awake now. And I kind of like getting started working like when I wake up. So before, I had been like waiting around for like an hour, and then I'd be like, oh, I really want to start working, but I don't want to start till I start streaming. So this just works better, right? I also plan on doing too, like October 15th or something this week. Okay, October 18th. So these 2 weeks, I am probably not going to be working. So, because I'm transitioning jobs, what I'm planning on doing is like 2 big stream weeks. So like all of these days, hopefully I'll be streaming around this time, and we're going to make some mad progress on this game. And I want it to be like pretty much done. That way, once that's all good, like ideally what I want is I want this week to be finishing up like the basics of the game. And then I want this week to be finishing up my math animations library. That way I sort of have all the pieces in place, and then I can start developing the tutorial series in this month. So yeah, hopefully that's the way it goes, but life never works out the way I want it to. So, or life never works out the way you want it to, right? There's always unexpected stuff. But anyways, yeah, so inside the update loop, we just sort of go through, and I have this input thing, which is a pretty cool thing. So the way I've kind of abstracted character controllers and stuff. I was having trouble. I was like, I don't like having the player controller like update the player and everything. And I was like, I want to abstract this out. So instead we have this idea of a character system, right? And a character controller. So a character controller just defines some like basic things about how, you know, an entity can move in the world. And it has this thing called a movement axis and a view axis. And those are basically just like, what direction are you looking and which way are you moving? And then it has these few booleans, which basically tell me, is it running? Is it locked to the camera? Do we apply jump force? We could probably get rid of the is running just by modifying that view axis, but we'll do that some other time. But yeah, and so this allows me to abstract things, and we'll see how this works out in a minute too, because it basically just means that now you can possess any entity in the world, which is really cool. And how's it going, Tree? Hope you're doing all right. So we'll take a look at that in a system, and this is kind of what this is for. I can sort of go around and possess the other entity in the world, and eventually we'll be able to do like the spectator mode in Minecraft, where you can like right click on any entity and then you'll be viewing through their viewpoint. So pretty cool stuff. I've also added tags, which you can see here. So I added 2 tag types. So there's player and there's camera. And that's just so that I can find entities easier and I don't have to pass around entities explicitly. I can just say, look for the tag with the player. It is expensive because you have to loop through all entities to look for something. So it's not something you want to do often, but it's there. And then the rest of the loop, I'd like to cut down on this eventually too. So yeah, but it's been cut down quite a bit. I'm happy with the way the code looks so far. And I'll hit play so that we can sort of see where we're at now. So you can see that I'm still inside of regular world, and I've gotten rid of the jitter. So like now you don't jitter and stuff. I have to fix too. So like you'll notice I'm moving fast this way, but then if I move this way, it's slow. I'm not sure why. I think it's something with my vectors, which I was experimenting with, but I'll figure that out another time. You can also jump now. So you can jump pretty easily, and it's working pretty good. It doesn't work 100% of the time because like when I hit this block, it thinks I'm colliding with that block and not the ground. So I have to figure out a better way to handle like physics collisions and everything. And then if I hit F2, no, that's F3. So I can sort of view some debug statistics, which is helping me out. I've just got the draw calls up there, player position, the player's position and chunk coordinates, and then the rotation, which you can see sort of changes as I move. And then if I hit F5, I'm going to possess this entity. So I hit F5, and now I'm possessing this entity, and I'm controlling him, which is pretty cool. So then if I hit F5, I'm back here, and I can sort of go back and forth. So this is really cool stuff. Like, yeah, thank you. Oh, and he has a higher jump boost too. I was wondering why he was jumping so much higher. Yeah, so this was just so I could sort of showcase like different character controllers can have different settings. And so since he has a higher jump boost, he jumps higher, and it's all data driven, right? We're not using explicit bindings or anything. This is all just sort of data driven. And so he can run faster than the other character too. So if I go back to him, he jumps smaller, he runs slower and everything because it's driven by the data. So it's just very cool stuff. Another thing that I kind of want to show too is if we go over here, you'll notice that we have a chunk missing. And there is a very specific reason this chunk is missing. So this is one of the reasons I started getting this debug stuff up. If you look up at the chunk in the debug stats, it says we are at chunk 0, 1. And so this chunk is 0, 0, which I'm guessing the reason it's not showing up is because of the way I am clamping coordinates and stuff. So basically I think 0, 0 is like getting skipped over. So I've got to review my generation techniques so that we actually get chunk 0. So yeah, if I jump in there, you can see that it is chunk 0, 0 and everything, but it's working pretty good. Another thing too that I noticed, which was kind of weird, is if I go into my renderer and we go down to, actually, let's go to draw string, I think it is. So inside debug stats, I'm drawing a lot of strings. So if I say render or draw string, this has a problem. And then if I go to draw texture 2D, this basically just draws texture triangle. And then if we go down here, we have these 4 slots. So let me run the game again. And you can see the memory usage over here, right? And so the memory usage is staying at 662 megabytes. But when I press draw the stuff, like, you'll notice it just went up a little bit there. And I believe it's still, yeah, it's still going up. Like, you can see the numbers on the left, they just keep climbing. So it's at like 710 and going up. And then I turn it off, we have no more increase in our memory usage. This is really weird though, because I'm not dynamically allocating any memory. Like, this is I've figured it out. It's these lines that are messing things up. So if I take out these 3 lines and I run this again, then we should see that we basically get the same thing, except once I turn on the debug drawing, so we're at 666 megabytes, and if I turn on debug drawing, you see we get the squares there, but we're not increasing memory usage, which is the way it should be because I'm not dynamically allocating anything here. It's very strange. I have no idea why we're increasing memory usage. I think if I drill down even further into this too, well, actually, no, it's just these lines specifically, because if we jump into this, the add vertex method, we're not doing anything special in here. So basically, and the squares are using this add vertex method too, which is why it's really weird, because like they're all using the same thing. So I just take in a const reference to the vertex. I basically just do some bounds checks, and then I just assign it. Like, there's no dynamic memory allocation going on here. Nothing weird. But for some reason, this is increasing memory usage. So it's really weird. I'm going to have to look more into that to see why the heck that's happening. Something I've never experienced in C++ though is when you have stack allocation that for some reason wants to increase that. Anyways, the topic of today is not that though. The topic of today is raycasting. So I've got my physics book up and we are going to start taking a look at that. The reason we're going to be doing raycasting today is because I want to start being able to break and add blocks, right? Right now there is no way to do that. So my thoughts are we do raycasting today, and then I'm going to try and implement the as-do techniques over the week, and then we will be in a good place to start adding and removing blocks, because that should make chunk generation a lot simpler. We may also do some performance testing, because I want to check how long it actually takes to generate chunk data and everything, because ideally what we want is like chunk render data generation should be like 1 millisecond is what I want the tolerance to be. So we're going to have to do some heavy optimizations there to try and get that to where I want it. Anyways though, I've sort of mocked it out in the physics library. So we got this raycast method. And eventually this raycast method will have to take in the registry. I'm thinking of splitting this up. We might have like raycast static and then void raycast dynamic. And dynamic is going to take in all the same things, except it's also going to take in the registry. So I'm still not sure how I want to do this. I think I'm going to have to set up some sort of spatial partitioning scheme for dynamic objects like custom entities and stuff. Because right now they're just sort of in the registry and we don't know where they are in the world. So we may need to split them up using like an octree structure or something so that we can figure out what we're next to pretty closely in terms of dynamic entities. In terms of blocks and stuff, which is why I called that raycast static, that's really easy to figure out because we just use our world and coordinates, and then we know exactly which blocks we're looking at and stuff. So let's go into physics.cpp, and right below this update method, we are going to start this. So the first thing I think we need to do, so we have the origin of the ray, the normal direction, and the maximum distance we want the ray to go. So clearly the first and easiest thing to do would be to draw this just to make sure that we are getting the correct statistics and stuff here. So we'll draw it from the origin, and then we're going to draw from the origin plus the normal direction times the max distance, and we'll do red for the style. So I'll say style red equals default, and we'll change the color to like E8 9. Okay, that works. 0101. Okay, and we'll do that in hex. Cool. So if we do this, we should be able to, or we have to call that function too, so I should probably write that out. And we're going to give that a kind of a length too, which I don't think I have on these lines, which it would be nice if we could like leave it on the screen for a little bit. So I might have to update the render eventually. Yeah, we don't have that right now. I'm not going to update that now because I don't feel like doing that. So we'll just have this draw line, and then inside of our player controller for now, we will just go ahead, and we have physics in here, do we? No, we don't. So we'll say include physics, and then down here we'll just shoot a raycast out from our player's origin. So we'll say physics raycast, and we'll go from our position, and we'll go to our forward normal, so that should be whatever direction we're looking, and max distance we'll do is 5. So I think that's Minecraft's max block distance too, is 5 blocks, so that looks good to me. Okay, so we should see raycast shooting out of my character. I believe we can't see it just because the line is like looking where we're looking. So let's actually do this inside of our character controller too. So we'll put it inside the character system. I'll put this like right up here for now, and we'll put a to do remove me. Okay, so let's just add physics in here real quick too. Okay, so we have our physics. We're going to do a raycast static that should draw a line looking forwards, and then we'll take this out of the player controller for now. We will want to move this back in eventually. But anyways, if we go back into the game scene, we should be able to see it shooting out of our other character. So if we move out, yeah, okay, cool. So now you can see it's sort of shooting out of that entity. And then if we switch entities, so if I switch to this guy, we should be able to see it, yeah, shooting out. And now it looks like it's pointing down because I was pointing down. And then if I point up towards him, then we should see, yeah, we get a line pointing towards me. Cool. So that's working. So this is going to be the basic structure. We're going to need, since it's doing a static raycast, it's not going to care about entities anyway. So it's not like we're going to get this as a false positive ourselves. But once we do dynamic raycast, we will have to worry about that. What we do have to worry about though is I think the first best thing to do would be to get all the boxes that this passes through. And that's going to be the hard part. Like, how do we tell which boxes this thing is passing through? So, some ideas are we could just like create a box at the origin, move forward 1 unit, create a box there, move forward 1 unit, create a box there, move forward 1 unit, create a box there. But I think we'll be skipping some boxes. Let's try that for now and see how accurate that is. So for now, we will just go into our physics. Okay, and then we'll go ahead and we'll say origin. Well, we got the origin, right? So the origin is right there. Let's just say like vec3 current origin equals origin. And then we'll say for float I equals 0 until I is less than max distance. And then we'll do I plus equals 1.0. Okay. And then we'll say box collider, current box. And we'll set this up. So this is going to have, actually, we should just have a default box because the boxes aren't going to change, right? All block, well, it might in the future. I'll leave this for now. So we'll say current box dot offset is 0. And the size is 1. Okay. And then we need a transform for that box too. So we'll say current transform equals, and then we'll set that up here. So we'll say transform.position equals current origin. And now we need to clamp this to like world coordinates, which I think I'm doing here somewhere. So we're probably going to steal that code. I know I'm doing it somewhere over here because I have a transform up here as well. Okay, so it looks like I'm just subtracting 0.5 from those coordinates, and then I just get the block at that position. Okay, cool. So that works good. So in this case, we're just going to leave it as is because that will work best. I don't think we really care about any of the other stuff, so I'm just going to leave that for now. And then we'll say render draw box. The center is going to be current transform, or actually, we do need to get the exact position. Yeah, so this is saying it's box pose, which is this thing. Okay, so it looks like what I'm doing is I'm sealing the position here. And then that's how I'm getting that specific position. Okay, so what we need to do, because what I'm trying to do right now is just get the specific positions of each of the boxes that Ray is passing through. So what I need to do is I need to, this origin could be anywhere. So we need to clamp it to a specific position. So we'll do the same thing we did down there. We'll say sealing that minus current box dot size dot x times 0.5f. So that should sort of get it to the center of whatever box we're currently in. And set that up properly, hopefully. We'll see. So anyways, we'll do that, and then that means that the position of the box would be this minus 0.5. So instead of doing this, let's do this. We'll say current origin does not equal origin. It equals the ceiling of the origin minus 1. Or actually, we could just make this 0.5. I need to abstract this into a method in the world so that we can do this much easier. Like get block position of this, whatever. We'll do that eventually. But anyways, so we get the transforms position here. Or I guess it's in the current origin now, right? And so what we can do here instead is we can say this equals, like we did here. Yeah, current origin, right? Or no, we're doing that minus 0.5 to get the origin, because the origin is the center of the block. Okay, so then we'll say this equals current origin minus 0.5. Okay, so now we're good. So this should center it on the block's position, and then we'll draw the box just to make sure we have this correct. The size is going to be the box's size, and we're going to do default style. Okay, and then after that, we're going to increase our origin by the raise direction, which is just the normal direction, times the, well, yeah, just by 1 unit. So this should increase us 1 unit in the direction of the ray. Let's see what we get. Hopefully we get the correct thing. Okay, so you can see some boxes sort of like in front of us, and they're kind of floating around and stuff, depending on the direction we're pointing. They look off right now, so if we look over here, yeah, they're all down a little bit too far. So we need to fix that, and they're back. So it looks like we're off by 1. So I think what I want to do is instead of origin minus, let's do origin plus here. And hopefully, or actually no, I think that's fine. I think what we need to do is change this to plus. And hopefully that will place them in the correct direction. So let's see if this works. Okay, looks like they might be too high now. We'll see though. Oh no, that looks like that might be right. So all of these boxes, almost. Yeah, so once we get to some rotations, it looks like they're not in front of us. What we want is we want all of these boxes to be in front of our cursor, because that means that they're all hitting the rays, right? And so if we look here, so all of those boxes are in front of that ray, which is good. But if I like, wait, no, now this is looking good. Oh, I think it depends on what position I am on the block. Okay, yeah, so if I do this and then we switch to the other entity, we're going to see that my ray is not passing through any of those blocks, which is not good because we want it to be passing through all of those blocks. First of all, I need to turn off the drawing of the blocks for certain entities so that we're not having it drawn in our face. Okay, so we'll have a bool draw equals true. and then inside of here, and then I'll say if draw. That way we can just turn off the drawing for now, and then we'll move this eventually once we finish debugging, and then I'll do an if draw here. Okay, so if we go back into there, the character system, just to turn it off for the player. So we'll say bool draw, or actually we can just say character controller dot lock to camera. Okay, so if it's locked to camera, we don't want to draw because that's the player. Okay, there we go. So now we should only see it in the other entity, which is good because we can sort of inspect what's going on. Okay. So yeah, so if I move away, there's no boxes drawing in front of me now. And you can sort of see that it is drawing appropriately. And it almost looks right because like all these boxes are centered, but I think that's because that guy is centered. So like if I move to the edge of a block and then I look in a weird direction, like off center, like that, then we should see, okay, so that ray is definitely passing through all of those blocks. So that's good. Let's see if it changes up. Are those blocks centered though? No, they should be touching like corner to corner. So that's definitely not right. This one is definitely centered. Okay, so this one's on a world block, but then this one is not on a world block. So I need to fix that too. So if we go into here, the physics, we're incrementing 1 unit in the normal direction, but I think we need to, after we do that, sort of do this whole thing again, just to make sure that we get that centered appropriately. So let's actually do this. We'll say this equals origin. And then down here, we'll say current origin equals, and then we'll do this, but we're going to use current origin. Okay, so that should make it so that we like clamp to the correct position every time. Let's see if this helps us out, because that might have been the problem. Also, guys, this is why you need debug drawing in every single game engine that you're developing, because if you don't have debug drawing, you cannot debug this type of stuff. So I guess that's an important note to add. Okay, so if I look over sort of that direction, let's see. Okay, so these blocks definitely are all aligned to our world. However, that one's definitely not in the position I want, first of all. So he's starting too far back and should be moving a little bit more to the left. So I think we're sort of losing track of our ray. So we need 2 variables then. We'll say glm vec3 ray origin equals origin. And instead of doing this, we'll say current origin equals the ray's origin, and then the ray's origin is what we will increment. That way we keep a point on the ray. Let's see if this helps us out now. Okay, so yep, that ray is definitely passing through all those blocks. So that's good. Let's see if we get the right thing here. So if I look sort of down there, let's switch. Okay, cool. So that looks like it's getting almost all the appropriate blocks. Something weird's going on right here though, because we're getting these 2 blocks, which I don't think, I don't know, that might be the right blocks. No, that's definitely not the right blocks. Okay, so we basically get that. Those ones are good, so it is going down, but then we need 2 over here, which we're not getting, and I think that's because these 2 are messed up. So let's see this again. Okay, so we say the current origin equals the origin, and then we get the ray's origin, which is going to be like the, I guess I shouldn't call that ray's origin. I should call that like point on ray. Okay, so this is a point on the ray. Then we're going to say the current origin equals the point on the ray minus half of a block size, so that we get the center of the block, and we raise that to the ceiling. And then we say the size of the box, all that stuff. Then we say this position is this current point plus 0.5. Then we want to increment the point on the ray by the normal direction. Yeah, that sounds right to me. I'm wondering if maybe we want this to be a plus too. So let's add that as a plus. And then we'll make this a minus. And let's see what happens. I think that might just do the same thing, just in a different way. So we shall see. Okay. So we've got our array there. That's looking good still. And then if I do this, I think, so what I ideally want to happen is for one of those boxes to be centered on this block. But yeah, you can see that we're definitely not getting that. This looks a little bit better though. I mean, it just looks like we're off by 1 in the direction going backwards. And then if we add 1 more to our forward direction, it looks like we should be hitting all of these. Maybe. Let's see. No, yeah, that's definitely not right. Because what we need is we need those points to be sort of in that block. So it looks like we're getting the wrong block depending on where we're at. Well, let me draw this out because that's probably going to be the best course of action for this. So I'm going to switch to the drawing screen real quickly. Okay, so I'm going to remove some of these scribbles first of all. So we'll think about this on a 2D plane because that's a little bit easier. Essentially what we have is we have some sort of ray that's going sort of in a direction like this. And what we want is we want to pick out each block that this ray is hitting. So let's do this in a different color. So we want like this block because the ray is in this one. We also want this block. We probably want both of these blocks because, yeah. Okay, and then we want this block. And we want this block. And we want this block. Okay, so that's basically what we want. The first problem which we have is sometimes we might jump too far and then we skip a block, sort of like this. And the way we can fix that is we can just increment our array in smaller bursts. So instead of going at 1 full unit in the direction of the array, we could go like 0.1 units. And then if it's a new block, then we add it and then we continue. Otherwise, if it's the same block, like so if we're here and then we're here, we just sort of keep going until we hit another new block and then we check this one. I think that's gonna be the best way to go. So we'll go like 0.1 or something. That makes sense. But how do we get this point to clamp to this center position? So what we can do, let's assume this starts at 0, 0. So if we just do this point raised to the ceiling, that should give us this corner, and then we can do minus 0.5. Okay, so that's all we need to do. I don't know why I was doing complicated math in there. So if we go back to the code, right here, I'm doing point on ray plus 0.5. I don't know why I'm doing that. I just need to do point on ray. So we ceiling that and then we go. So this should get us the correct points, but we might need to go in a smaller increment just to make sure we don't skip any boxes on accident. Okay. So let's check and see if this is working right. Cool. So that looks good. Right. Yep. I think we're still off by 1 because I'm starting too far back or something. No, that looks right. I think we would count that block. I might start just a little bit sooner though. Okay, so if I look towards that block though, and we hit F5. Okay, there we go. This looks better. So now we're getting, we start there, we hit this block, that is correct. We get this block, that's correct, that's correct, that's correct. Cool, okay. So those are all definitely hitting the right blocks. But I think there are going to be cases where we miss some, right? So if I look in a weird direction, I don't know, let's try this and see if we skip any blocks on accident. So that's close to skipping a block, right? We kind of get this corner. And I've somehow managed to get that lined up perfectly where it's like right in the middle. So, but if I change this view a little bit to the right like that, and then we look again, yeah, I think you can kind of see that. Yep, okay, you can definitely see that. So you see we're skipping that block in between. So the fix to that is, like I said, we just go 0.1 increments until we hit something new. I also think we're not quite reaching our view distance. So yeah, we're not really reaching the end of the view distance. So if we increment it in 0.1 increments, that should help with that too. Okay, so first of all, I'm going to do current ray origin. Well, yeah, we'll leave that. And then instead of going in 1 increment, we'll go 0.1 increments. And we're basically going to keep going until the current origin is new, right? So we should check. We'll say if glm ceil point on ray does not equal current origin. So basically, if we're at a new block position, then we do everything. Otherwise, we will just increment our ray by the normal direction times 0.1. Okay, and that should be good. Let's see how that works out. And I might want to change the way I'm sort of doing this loop to a while loop, because that makes a lot more sense anyways. Okay, so yep, that still looks good. And then if I do kind of a weird position like we were before, so if I kind of look slightly to the right like that. Okay, cool. It looks like we're getting all the boxes that we're passing through. Yeah, sweet. So we kind of get that zigzag, which means we won't miss any boxes, and we're also getting that last endpoint. Cool. That part was way easier than I thought it would be. Now the only problem is when we're raycasting, we kind of have to check each block. But since we're going kind of in this zigzag direction, first of all, we can skip the raycast, which is going to be expensive. Once we actually get to the actual calculation, we can skip the calculation if it's an error block, right? So most of these will be like skipped. But then we can also stop. Okay, yeah, that's what I was thinking. So if it's a solid block and we actually have to check it, we can basically stop. So this is good. So basically when we're raycasting, this may look bad because we're going to be checking all of these blocks. So it's like we're doing 1, 2, 3, 4, 5, 6, 7, 8 raycasts, but that's not true because we're going to be skipping for all of these since they're all air. And then once we actually hit a solid block, we're basically be looping forward till we find a solid block. We find a solid block and we kind of stop. And actually, yeah. Okay, and then we'll stop. I was going to say, actually, we could just stop there. And then, like, if this is solid, then we know we've hit it. But we'll have smaller blocks in the future. So we'll probably want to actually implement, like, a real raycast so that we can do different size blocks in the future. But yeah, this is good. For now, though, if we wanted to, we could say, very simply, so we do all this, and then we could basically just say, let's get the block, which I do right here. So let's get these things. We'll say that. So we're getting the block at our current origin. I guess we could say current transform dot position. Then we get that block format. Then we could say if draw and block format dot is solid. Okay, so watch. Now if we do this and I remove this sort of... Actually, I'll just change this to true, where we're drawing somewhere. Okay, yeah. So we'll just remove this for now and say that's true. Okay, so now we're going to... This is like a super simple raycast, I guess. And Essie Woods, how's it going? I hope you're doing all right. So... This is like a very, very simple raycast. It's not technically doing anything, but there we go. Look at that. Hey, look at that. So now for every solid block we have, we sort of have this border showing up around it. And we're starting to get like a Minecraft feel, right? I'm excited. This is actually working better than I thought it would. And then if we want to really get this going good, we can just say, once we hit a solid block, we'll just say return. So we'll do that for now. This is not how we want it to function in the future, though, because we actually want to check the box bounds and everything, because there will be boxes of different bounds, and we can't really just do this simplified. Okay, look at that, though. So now we have a way to see which block we are pointing at. And it actually works much better than I thought it would. I'm really happy with the way that works, and that was way simpler than I thought it would be, too. So now we can sort of pick different blocks. Eventually what we want to do too is break blocks and add blocks, which is the harder part. Man, I feel like I could call it a day done and we're good here, but we're not. So first of all, too, I want to say, let's set up a style here. When we initialize our physics, do we initialize physics? We don't. Okay, let's add an initialization method here, first of all. Because what I want to do now is I want to say static style block highlight, and that's going to be nothing initially. We'll have a void init method here, which should initialize these things, and then we'll say block highlight equals styles default, and then we need like a kind of a half transparent image. So we'll say block highlight, whoops, dot color equals hashtag, and then we'll do like a black color, so 000000, and then we want it to be semi-transparent, so we'll do like 66, 67, semi-transparent. Okay, and then we'll do that as hex, and that should be good. Then down here, we can just say, instead of drawing this in the default style, we'll say block highlight. We also want to change the stroke width on this too, because it was a little bit thick there. So we don't want that to be as thick. So we'll change this to 0.02. Looks good, yeah. Maybe, I don't know. What's the default style? Let's check that first. 0.05, okay, so 0.02 should be good. We're gonna do that, and then let's go into our world and initialize our physics. Or actually, I think that's our application that we want to go. Yeah, and then we'll initialize our physics inside of here. So we'll just add in a hash include physics, and we'll initialize that guy right up here, right before we do the world. Yeah. This is another reason too. So if we were doing like object-oriented programming, we could probably do something where like all of these systems inherit from a same class that has an initialization method that I override. The reason I don't want to do that though is, first of all, not all systems need to be initialized. Second of all, if you split it up like this, you have explicit control over the order of initialization, which is very important because, for instance, we need to initialize this registry before we initialize this window. We need to initialize the renderer before we initialize the fonts. So like, being able to explicitly control these things is definitely very helpful, and sometimes we like to over abstract as programmers instead of just writing a few extra lines when those few extra lines could be very helpful. So yeah. SEO, do you use Blender to create characters for a 2D game? Oh, cool. Then you use the animation mode in Blender to create the poses and just save the different poses as PNGs. Is this dumb? No, I think that's really cool. That's actually awesome, man. Oh, cool. Look at this too. So we've got like kind of a very thin highlighted line going around our blocks. But yeah, I think that's pretty cool though. And there's a program called Spine 2D. Oh yeah, I have heard of Spine 2D, but it's paid. So like if you don't want to pay for it, I would definitely say keep using Blender. And Joe Mega just came to the stream. What did you get? A FIFA 22 commercial. I am sorry. I would not have made you go through that because FIFA, I don't know. Does anybody play FIFA? Like, I know there were a few jocks and stuff in high school who really liked FIFA, but I never really knew anybody who played a lot of games that played like Madden or FIFA or anything. So you did before. Okay. I'm not judging then. A lot before. Oh no. Nothing against FIFA. Like, those games are pretty, they have a lot of stuff going into it. So it's still like definitely a pretty heavy duty game and everything, but I'm not a fan. I'm not a fan of a lot of games though anyways, so. And you use two languages too. Okay, so I really can't speak then. Joe Mega, how to make a new FIFA, literally recycle last year's game. Yeah, I think that's my biggest kind of argument with that type of game is that they just reuse, or it seems like they do. But then again, you have games like Call of Duty, which are basically the same game every year. And then Halo, which is basically the same game every year. So, you know, lots of games are doing it. And Tree, FIFA was good back in the days, but now it's just a copy and paste change. Yeah, but you could say that about a lot of games, right? I mean, and then technically Minecraft did it right. They just update the version, so it is still the same game with just new features. This is looking pretty good, though. I think we need to implement real raycast, though, because this is not going to be the best. And I also want these lines to always appear on top. Right now, they kind of get clipped by the block. a little bit. Like you can kind of see it changing width there. And I thought I should be avoiding that because if we go back into my renderer, or I guess the world, the way I'm doing this, yeah, I basically render all the chunks, and these are actual physical draw calls. I'm going to change that in the future though, so that this will be more like draw commands. And then I render the line stuff. But I guess technically it could render early, huh? Because basically the way that the line renderer works is it just sort of flushes everything to the screen as soon as it's done. Okay, I think what this really sounds like is I need to set up a few different render passes and defer my rendering so that I actually have this set up the way it should be. And then I can composite the 2D display over the 3D display in a future pass. So yeah, the render is going to have to go through some heavy duty stuff too. But let's start looking at some super complicated math to figure out how a raycast works for a box. I'm looking forward to that. Aren't you guys? Just kidding. I hope you're not, because math isn't fun all the time. Yeah, there aren't that many original games too. I agree. But, yeah. And you started on your math library, Jomega. And you had to put it on hold. Yeah, SIMD can be annoying. That's why I use GLM. I mean, I don't know. I've never done SIMD, so I wouldn't have any room to speak. But I figure it's easier just to use somebody else's, right? So when one day I want to actually look at how SIMD works, I'll try and implement it myself. But for now, I will just use GLM. Okay, so I'm going to be following along with this book to figure out how to do raycasting because this book was very good. Okay, so let's go down to 3D primitive shapes, and then we're going to look at ray intersections. Okay, yeah, so raycast an axis align bounding box. This is what we want. Cool. And I remember this took me forever to comprehend the first time, so we'll see if I can figure it out pretty quickly. So it says, any ray that intersects AABB will do so twice. The first intersection is where it enters, and the second is where it exits. If we know both points, then the point closest to the origin of the ray is the intersection point. That's true too, because we may want to get the intersection point. Do we? I don't think Minecraft ever uses the intersection points of its AABBs. Or like its raycasts. I don't think there's a single... So we might not even care about that, but I'll still do it just for fun and profit, right? Okay, so we can simplify finding the intersections by visualizing the problem and looking at the XY axes only. So in this example, it's represented by two slabs, the intersections and the planes. And we can see which slabs it's hitting. See, this is the part I never really understood. So they're unfolding the box, which that makes sense to me, right? We're just unfolding the box here. But how does this work? Like, this still doesn't make sense to me, right? Because we can't really project it all onto a 2D plane like this, I don't think. But I think this is just for visualization. This might not actually be how it's working. Hopefully. So we find 2 points as a result, tmin and tmax, and we just return tmin. Okay, and we need to return the smallest tmin because we could hit 2 slabs. Okay. So we have 2 more points, tmin y, tmax y. The ray enters y slab and leaves the y slab. There's no intersection. Wait, and then leaves the X slab. So this means there is no intersection. Okay, see, this is what I'm saying. Like, this makes no sense to me. How are we doing this? And how does this tell us that there's no intersection? The greatest minimum value of tmin y, tmin x is greater than the smallest maximum value tmax x, tmax y. So we can see what the slab method does. Yeah, so he's saying it needs to actually happen like within this section in order for there to be an intersection. I need some 3D visualizations. Like, if this guy had some animations with this stuff, that would have been awesome. For now, we'll just look at the code and sort of copy it because that's going to be the easiest way to do this for now. And then in the future, when I make my tutorial videos, I'll make a 3D animation that explores how this actually works so that hopefully I can understand it better. Animations and books, they need it. All books are PDFs now anyway. Anyways, let's get real here. Especially like crafting interpreters. If he added animations, that would just put his book over the top, right? This would just be perfect now. I also really like his website too. Just like the way he set this up. It's just so great. And then he also has mobile support too. I think if you go into like mobile mode, if you do developer options, which Opera doesn't let you do with F12 for some reason. Dev tools, Control-Shift-I. Yeah, I don't like that. But like, look at that. I mean, he even has this optimized for like, or not optimized, but flexible and everything. That's great. Okay, anyways, sorry. Let's go back to this. I'm just going to copy this code and that should be good for us for now. And then one day I will hopefully actually understand what's going on. So, okay, so for now though, we want the raycast to return a float, which is basically, I'm going to abstract that into like a raycast result or something. So if we go into physics.h, let's just add a structure up here. Raycast result, and this is going to have like GLM vec3 point of intersection or whatever, right? This is the colliding point. Bool hit, which just tells us whether it's hit. In the future, we can add more data to this if we need to, like adding the actual body that was hit and everything, which may be a little bit harder in the terms of like static raycast versus dynamic. But for now, this will be good. And we will just be returning a raycast result. And as a copy, because I think return value optimizations will get applied, hopefully. So we'll say raycast result up here, result dot hit equals false. So that should be fine. And just sort of catching up on chat real quickly. So those two images are just tiny part of the internal stuff. They will be wrapped in a pack and mask tape. I'm going to check out your images real quick, Joe Mega. Let's see. Okay, so you got your code. Yeah, so basically SIMD is just sort of you're sort of using all the registers on the CPU, right? I'm pretty sure. So that's what it looks like you're doing here, and this just looks really complicated and like stuff I don't want to do anytime soon. So I'm pretty sure like SIMD isn't that complicated conceptually. It's just a lot of work, right? Correct me if I'm wrong, Joe Omega, but I don't know. I haven't worked with it too much, so I can't say too much about that. Okay, anyways, though, we've got this. We need to get the min and the max of both AABBs according to this. So we get, or I guess this is just getting the min and the max of the AABB. Oh, that we're currently working against. That makes sense. Okay, so we do all this. And then right here, we're going to say, so if this block is solid, we're going to say if draw here so that we kind of do that. Actually, I'm going to leave this now because now we actually want this to sort of work. If we hit it. For now, though, we're going to return result down there. Yes. Okay, cool. And then up here, what we're going to do is what he's doing now. So this is where the actual raycast. So if the block is solid and everything, then we actually have a potential candidate for a block that we might be hitting. So we'll get the minimum and the maximum of that AABB. So we'll just say glm vec3 min equals the current transform dot position minus current box dot size times 0.5f. We might need to add in the offset too. So plus current box dot offset, and we'll sort of work with those in the future. Catching up on chat again real quick. Yeah, so you're using special parts of the ALU. Okay, cool. And it is quite some work. Yeah, that's what I figured too. Tree, why do you want intersection points? Minecraft doesn't use them, and every block is just a block or a slab. See, yeah, that's what I'm saying too. Like, I don't think you really care about intersection points. We do need to implement this though. So the reason we're implementing this, right now the way my intersections work is, let me go to my drawing screen real quickly. So I've sort of mocked up a fake raycast, right? So basically if we have a ray that starts here and ends here, what I'm doing is I'm incrementing in 0.1 increments, and then I'm just getting the bounding box around this specific cube. But that doesn't actually tell me whether I'm intersecting with this actual cube or not, right? Because we could have like a lantern, right? And a lantern is small, and so the lantern could actually be placed down here. And so even though we could be hitting like this cube, this ray is definitely hitting this cube, we don't really know if it's hitting this lantern. So I need to implement real raycasting just so that we can very easily check and see if we're hitting any sort of other objects. Don't know if we need the intersection points and stuff, but that might be useful in the future and everything too. And tree collision has to be real, of course, and it can't just be a block or a slab, but the raycast doesn't. Yeah. But for those smaller things, it'll be nice to have like an actual raycast thing. So, oh, cool. And you got Intel intrinsics guides. Let me see that. And this looks, wow. Yeah, okay, I guess this is good for reference, but you have to do that for all different vendors too, don't you? You can't just do that for Intel. You gotta do like AMD and everything else too, which that's not very fun. Tree, but if you have collision, you might just make real raycasts. Yeah. The collisions aren't really real too, right now. Like I'm doing sort of a hacky Minkowski difference thing, but yeah. Like I said, though, the real reason we're doing this is just that we can check if we're hitting smaller blocks that might be offset from the origin and stuff like that. So then he gets all this stuff. Any direction could be 0. Avoid a division by 0. You need to add additional safety checks. Okay, cool. So we'll do all that stuff too. We also need to get the max, which I totally did not do. So vec3 max equals current transform dot position plus current box dot size times 0.5 plus offset. Okay, and then we need to check and see if the ray is 0 in any of these places. For now, we'll just get all this stuff. So I'm gonna see if I can copy this. It doesn't look like I can. Maybe I can. There we go. Okay, so copy that, and that did not paste very well at all, but we'll fix this in a minute. So do that. Okay, and then we're gonna add in protection check things here anyways in a minute. And this will use, I guess we'll just use the origin, right? Yeah, because it doesn't matter specifically where we're going. And then we'll use the direction, which is the normal direction. Yes, so we'll say normal. Okay, cool. And then we'll add in those checks in a minute too. Basically, we just don't want to do this if this is 0, because we could have these 0 and then that would be a divide by 0. I think we can check that though, because like float NaN. No, I think C does support like not a number things, which is weird, but it does. So yeah, those intrinsics are part of x86, so you just need to decide based on the instructions that's the CPU supports. Okay, yeah. Oh, okay, so different vendors, Intel and AMD are the same when it comes to, oh, okay, cool. I totally thought that different vendors had different instruction sets completely. So like x86, I guess, is the instruction set for like 64-bit, or that's 32-bit operating system, right? Does 64-bit operating system have different, or is x86 just sort of the instruction set for both of those? And then if you have ARM support, okay, yeah, so ARM is a different vendor. And do those have different instruction sets too? CPUs are things that I have not worked with in the past, like assembly and everything. But yeah. x86 64 is a superset of x86. Okay, cool. So you can do x86 code, and that still technically works for that stuff. Yeah. Would I use Box2D for lighting and Jade Engine? It depends on what you're doing with the lighting. So 2D lighting is different than like 3D lighting, right? Because it doesn't quite work the same. I think I would probably roll out like a custom lighting system entirely. Like the way that we're doing lighting here in this game, which is just like very simple lighting right now anyways, is if I go into the shaders. But this is sort of like how basic lighting works anyways, right? Is I think we just get, okay, yeah. So we get the normal, we get the diffuse, and then we sort of multiply things around inside of the shader to get the object's color. And you sort of use the dot product between the light's direction. Yeah, so we get the light's direction of the sun position or whatever to whatever this fragment is. And then we get the normal and calculate what the shadow should be there. So, and you want the lighting to look more like the game is 3D. Yeah. So this is like 3D lighting and how you typically go about this. So you don't really need like a physics engine for the lighting per se. The only thing you do need for the lighting, like, is you need to be able to do some sort of spatial partitioning scheme so that you can see which areas the light is hitting. So if you're saying that, then that does make sense, because you would need to like sort of see which objects the light's affecting. And I think Box 2D could help with that. So yeah. And is it me, or did that look something like a switch in there? Did I have a switch in there? I don't think I did. Let's see. Okay, I do. Yeah. So I have a switch. Probably not the best. I shouldn't have any branching in here. But why am I doing this too? I'm doing this just to get a vector 3. Yeah. The reason I'm doing this is because I'm like compressing the data and then pulling it back out. But I definitely shouldn't be doing this in the fragment first of all too. I'll fix that up later. For now, it doesn't matter. The shader's super simple anyway, so it's not like it's going to affect performance too much anyways right now. But yeah, not good. Yeah, it is. I know, because of the... Does a switch statement affect the GPU the same way though? Because it is like different. I know on the CPU it's different because you can jump directly to the instruction. Let's see. Does a switch... Well, let's just do performance of switch statement on GPU in a shader, because I am interested in this. Using a switch command in one shader versus multiple shaders. Branching of any kinds, yeah, so best avoided. Mildly true on the PC. And especially true on some CPUs. And especially true on GPUs, yeah. So I will definitely be taking that out sometime. The reason that I figured it wouldn't affect the performance too much too is because inside that specific switch, it should be the same for all fragments in that specific triangle, right? Because the way it's just passing in a flat vec2, which is the face is normal. So I don't think that changes, but I still should change that. So that's in the future though. And let's see, do I consider myself a shader god? Definitely not. If different threads in a single thread group have different branches, it gets painful. Yeah. Yep. So that's why I figured it wouldn't be too bad, because it's like it should all be executing the same branch, but I need to get some actual GPU benchmarking stuff up and everything too to actually check that stuff out. For now though, like I said, it doesn't matter. I will be fixing that though. Okay, so we get those t values, find the largest minimum value. I'm just going to shamelessly copy this too, because I don't want to understand theory right now, but I will once we actually go ahead and make this. So I'm going to use GLM max. Can you do multiple parameters in this too? No. Okay. So we'll do GLM min here. There was once upon a time when I actually understood this. I could probably watch the video I made on raycasts for 2D boxes, and I know it's very similar to this if I want to figure that stuff out, but I don't want to think too much right now, just sort of get it working. Okay, so we'll say GLM min. Wait, yeah, okay. Want to make sure I'm not doing that wrong. So, and then the minimum of the maximums. And if Tmax is less than 0, the ray is intersecting the AABB in negative direction. This means the AABB is behind and should not be treated as an intersection. Okay, so these are just the different cases too. Okay, cool. So we'll just have that, which means no intersection. So this is no intersection. What were the other two cases too? If Tmin is greater than Tmax. Okay, so, or Tmin is greater than Tmax, that's no intersection 2. And then if Tmin is less than 0, we return Tmax, otherwise Tmin. So if Tmin is less than 0, that means the ray intersects the AABB, but its origin is inside the AABB. This means that Tmax is the valid collision point. Okay, so this is a good point too. If a raycast starts in the origin, do we really want to return that? Because basically that means you're starting a raycast inside of an object. I don't know. That's kind of a difficult thing. For now, I guess we will, but yeah. Okay, so we'll set that up to if tmin is less than 0, then we're inside of the origin, or the ray's origin is inside the AABB. Okay, otherwise we return tmin. Okay, and then so we'll say float penetration equals 0. This will, I guess this should be depth. That way we can calculate the actual point. So then we'll say depth equals tmin, tmax. Right? Okay, yeah. And then otherwise depth equals tmin. And I'll probably change this up in the future to a ternary or something, but I'm leaving it this way because I want to have that comment there just so I can remember that. Okay, so then we get the depth, and then we can get the collision point just by saying, or actually I guess we could say result dot point equals the ray's origin, which I called origin, plus the normal direction times the depth. Okay, so that should give us the point, and then result dot hit is clearly true at this point, and we'll return that result. Okay, cool. And right here we will return result, which should be all false and stuff at that point too. Cool, so this should still do the same thing basically, but now we're actually doing a proper raycast. And I don't see any, yeah, since the boxes are axis aligned, this isn't really that expensive. Like, we're just doing a bunch of mins and maxes here. So that's really good to hear, because that means that we don't have to worry about raycasting being an expensive operation in this game, which is cool. Yeah, because I think once you get to like oriented bounding boxes, you add in a square root there, which is why the raycast can start to become expensive. Let me check up on the chat real quick too. In general, GPU runs 32 or 64 instances of a shader at the same time. So conflicting branches mask out and execution masks. So it needs, yeah, that's like the warps and all that stuff, right? I really need to start looking into like some CPU stuff and everything, but from what I understand, it's complicated stuff that I shouldn't try to understand at this point. But I will remove the branches. For now, it's just because this is still very much in development, and I don't care about that type of stuff right now. But yeah, so it looks like our raycasting is still working appropriately. One thing I do want to check, because that would be interesting, is if inside of here, and actually we shouldn't be drawing inside of the raycast. That is true. So we should remove this out of there. And then we should say character system, raycast result res equals that. If res dot hit, then we'll draw. And then what are we going to draw? We're going to draw. See, this is why I probably need that bounding box information, because then we could draw the bounding box and everything here. For now, it's fine. Okay. Actually, no. Yeah, let's add it to the raycast result. This is going to be raycast static result, because I'm separating raycast into dynamic raycast, which are against dynamic entities, and then static raycast, which are against the world itself, so just blocks. And I'm separating that out because we're gonna have to come up with a new spatial partitioning scheme, and since these are not entities, it's a little bit harder to return information about that. So yeah. Anyways, though, we got the point, we got the hit, and then I'm also gonna return in here the transform, or I guess just the position, and the size, center, and size. Block center, block size, because we know that these are going to be blocks. Okay, and so this just sort of simplifies things a little bit more for me. And then let's copy that, go back into here, we'll fix that up, and right here we'll just say result dot block center equals, and we want to get the block center that we're using, which looks like is current transforms position. Okay, so we'll use that. Oh, wait. Yeah, current transforms position plus the offset is what that guy should be. So we'll do that plus current block dot offset. Nope, I still messed that up somehow. Current box dot offset. Okay, and then we can say result dot block size equals current box dot size. Okay, cool. So now that information is stored inside of our raycast result. So inside of our character system, we can go ahead and say that this is a raycast static result. And if we got hit, then we're going to draw the box at the res dot block center, res dot block size. And we'll use the block highlight, which I put in the physics, and we don't actually want that in the physics. So let's remove this. And we'll put that in the character system. I guess technically this should be in the player controller because that's where we want it. Only the player's blocks get highlighted. But yeah, we'll put this in the player controller actually. Okay, so I'll put this up here. And then we'll have a initialization for player controller and all that stuff. So we'll just do void init and then go back into here, grab this, remove all this stuff. I'll leave the initialization method just in case I need to initialize stuff later. We'll do this and then we'll grab this out of here. Removed it is, so we're good with that. And then down here, we're gonna say this. So if we hit that stuff, then we draw. Cool. Okay, so that should be good. Trying to think if I'm forgetting anything. I think we're good. We just need to initialize the player controller now, which I can do inside of application. Not sure if it should go in application, but I'm going to put it here for now. So we'll say that player controller, and then we'll just do player controller init. This to do should probably move this into world. Okay, so if we run this again, we should sort of get the same functionality, just a little bit different. And we've sort of abstracted all this information away, and we should be using real raycast too. And I didn't even do the thing that I wanted to do. Okay, so yeah, so this is still working right. We're getting all the raycast information still, and it's still pointing to the correct blocks. And if we look too far away, it's not getting those because they're in front of the raycast. The last thing I wanted to do too was inside of here, I want to say render draw box. Eventually we'll have like points and spears, but for now that doesn't work. Res dot hit, no, res dot point. So that's the hit point. And then we'll just do like a glm vec3 0.1. So just drawing a mini cube where we hit it just to see if we're actually hitting it. Okay, so let's see if this works out. I'm going to catch up on chat real quick too. Also, to give you an idea, you have maybe 2% of SIMD abstraction already at around 1.3 thousand lines. Dang. Yeah, that's quite a bit. Okay, cool. Look at this though. So we've got that mini cube, which follows where we're hitting this cube. So our raycasts are working good. We can determine where we hit it exactly. Not because I'm smart or because I knew what to code, but because I stole somebody else's code. But good thing that it works. Do I have any new next YouTube videos planned? I'm probably gonna make the next one today or tomorrow. And release it on like Wednesday so I have time to edit and everything. But I was debating doing like a refactoring video for the 2D game engine thing, or doing const in C++ because I kind of want to wrap up the C++ beginner series type thing. I still don't know how much I like that series and everything too, because there are just I've had some people not happy with it just because I don't understand all of C++. I don't think anybody does, but everyone always has a problem with the way somebody else uses a subset of C++. But anyways, that's besides the point. So either that or that video. And then I was telling the other guys who are here too, a little bit earlier in the stream, I'm going to be taking off a couple weeks in October. So these 2 weeks here in October. And why? Okay, yeah. And then what I plan on doing is like streaming, hopefully every day. Maybe not. Maybe like Monday, Wednesday, Friday these weeks at the same time that I started today. And we're going to be getting a lot done with this game. So hopefully like sort of finishing up this game, and then also the math animations library, so I can start the Minecraft series. So yep. And you haven't started the series, but you know you'll get to it at some point. Yeah, you're good as to what's. But I want to start making higher quality videos, especially for this series. I talked about this too in Discord a little bit. But basically for this series, what I want to happen, not C++, the C++ series, I don't want it to be as high quality, but for the Minecraft tutorial series, I plan on doing just conceptual videos, because my inspiration is actually coming from this guy. I think this is the best tutorial ever. Like this book, I have never had a better tutorial. And I want my next series to take direct inspiration from this. And one of the things he does at the end of each of these is he has these challenges, and he doesn't give the solution. But these challenges are parts of your interpreter that you'd actually want to have. So like the whole book is about writing a programming language, right? And he actually adds in things where it's like, oh, you probably want ternary statements, but I'm not going to tell you how to do that. And I kind of want to do that with my next series, just so that we actually, like, people actually learn. Because I feel like with my series right now, it's more like passive learning. You don't really do stuff. You're just sort of following me. And so I want to make it so it's really, I'm pushing you to say like, you're coding this yourself. So we'll see how that goes. It's going to be experimental. I have no idea how it's going to turn out, but I'm hoping it'll be good. And Omega, so just an example, how to set 256-bit register with bytes and through. I didn't know they had 256-bit registers. But yeah, this looks as painful as I thought it would. So this is why I don't want to do this stuff. But this is why they give us libraries like GLM, so we don't have to worry about this stuff. I'm interested though now. If we look at GLM, I think they have like a performance thing, GLM config SIMD. They probably got a crap ton of stuff in here too. Yeah, like I think this is all check inclusions of different versions of, like, just for different versions of C++, so that they don't have any problems with like, yeah, the build targets and everything. This is insane. But anyways, yeah, this is why I don't want to deal with this stuff anytime soon. But yeah, SEOs have definitely learned from you in the past series, but there are many ways to teach and learn. Thanks. Yeah, I appreciate that. And I'm always, I don't know, I'm hard on myself because, like, I think that we can do better as tutorial makers. Like Cherno, I love his series and stuff, but I never really learned from it. It was more just like I kind of followed along, and I passively absorbed the information, but it didn't really sink in until I started coding stuff myself, which is a pain because you want to learn from the tutorial series you're watching, right? So yeah, that's why I'm going to really push people to like code things themselves, and I'm going to hopefully not include all the code so that you're forced to code things yourselves. But we'll see how that goes. Anyways, though, I mean, this is pretty good. I am happy with where we got to in this series. I mean, this episode, whatever this is. We now have Raycast. We can tell where we're hitting. I need to start adding the ability to break and add blocks. I'm not going to do that in this episode because I plan on overhauling the way I'm rendering things right now, using the as-do techniques that I sort of talked about, approaching zero driver overhead. So like modern OpenGL, because I need to start learning about that stuff, and that's sort of like how Vulkan works anyways. So this will give me a good head start into learning techniques that are better for graphics programming. So once I do that, this whole chunk system will probably be overhauled quite a bit, and we'll have like a better way to add and remove blocks, which is my plan. But I did talk about benchmarking things, so maybe we should benchmark stuff real quick. I'm going to commit this stuff, though, just so that we have this separated. So let me just do this. Okay, and we got that. And we got that. Cool. We could do benchmarking, or we could do like GUI stuff, because I kind of wanted to start adding in. So we've got like that GUI stuff, right? Where we've got this. Oh, actually, Joe Mega, since you're here and you know a lot about C++, maybe you can help me out with this too. SE Woods, and you've always coded your own projects as you follow along your series, so in that way it works really well. Awesome, yeah. That's the hope that people do too. And modern OpenGL is still far away from Vulkan, to be honest. Yeah, I know that too, but it's closer, right? It's closer than what I'm doing right now, which is basically the most basic OpenGL you can do. But Joe Mega, if you're here, and I think you are. So one thing I want to point out is, like, over here, you can see my memory usage. It's at 770 megabytes, and it's staying there, right? 700 technically. But then as soon as I turn on my draw rendering stuff here, it starts going up. Like, you can see the numbers going up to 784, 785. It just keeps going up. The thing is, I'm not doing any sort of dynamic allocation here, which is why it's really weirding me out, because I have no idea why it's doing this. So if we go into debug stats, which is where it's getting drawn. So if I go debug stats.cpp, yeah, I know, that's what I'm saying. It looks like a memory leak, but I'm not doing any sort of dynamic memory allocation. So it's these functions in particular. I've narrowed it down. And if I go down into here, if I comment out these 3 lines, we can do that. So once I do this and we take a look at this again, if I just move this out of the way. Okay, so it's at 662. And then once I turn it on, did I do that right? I might have commented out the wrong line real quick. Let me check that one more time. Yeah, that's the wrong line. Whoops. Okay, so it's actually this draw textured. Yeah, so this is the one that's specifically causing the problem. So if I comment out these lines and we go back into here, we'll sort of see what's going on. Okay, yep, so I'm at 663, and then if I hit F3, we've got the boxes drawn up there. There's no text. No memory leaks. It actually went down a little bit there. So it's just staying the same, right? What are these 3 lines doing? They're not doing anything particularly interesting. Like if I just jump into here, all this is doing is it's doing a bounds check. So I'm making sure that I'm going to be inside of this array. And then I'm just copying data to this array that's already sized. Like, yeah, this is all that's going on. You know, like this isn't something that's particularly, I don't see how there could be a memory leak there, is what I'm basically saying. So it's just really weird. It might be something else in my code that's causing that. If I comment this out, like you'll see that it won't do that too. So like if I go back in, I won't be able to draw any lines though, because this is what I'm using for all of my lines, which is why it's also weird. Because you'll see I don't see any lines now and I can't turn anything on and we have no memory leaks. But the 3D lines and everything are using this same function. So like, I know it can't be this function because other things are using it. It's just when I use it in the context of this that it starts to freak out. And it's just these lines that are causing that. So yeah, really weird. I have to look into that a little bit more, but yeah, what's the data? The data is just a pointer. So if I look at this, just a T star. And I have that initialized here with just this, and this gets called once. I think what might be happening too, now that I'm explaining it too, is this might be creating new batches. But see, that's the thing that doesn't make sense too, because a batch is pretty big. So I feel like that would add a lot more memory. But this get batch 2D might actually be the problem. Or this create batch 2D. Let me do that. Maybe this is the problem. So if I do that, I have some warnings that should be logging though, in case that type of stuff happens. And then move that over. Okay, so we're kind of there. Oh, okay, maybe that's the problem. Maybe I just found it. Thank you, Jomega. Cool. So that's good. I guess I was creating extra batches. Your question about what's the data kind of clued me into that. Okay, so it looks like this thing is kind of broken. Then I guess it shouldn't be doing whatever it's doing. Please to happen, you're rubber ducky. Yeah. Usually that doesn't work out that good. Okay, so let me just put a to-do in here and I'm going to fix this off stream later. Fix this. It's broken. Okay, so anyways, so we have performance testing, but I also wanted to start adding in like some sort of GUI thing. So let's go ahead and I'm not sure where the best place to put this would be. Let's go and do Minecraft include source gameplay. Okay, this is where I'm going to add it. And we're going to call something called like a command line interpreter or something like that. We'll just call it command line. Okay, so we'll have command line .h. Well, rubber ducky that can ask questions. Yes, that's true too. You're much better than a rubber ducky because you can point me in the right direction and stuff. Man, I was looking at that for like hours the other day and I was like, why the heck is this increasing memory? Like I'm doing static allocations here. So, and I guess that's the beauty of C++. You can comment out one thing, but it's like something else. I guess that's any programming language though, right? If you program it poorly, you can screw yourself over pretty easily. So, okay, so let's have a command line.cpp in here too. Let's close that stuff out. And inside of here, we'll say hash, if not define, this, define this, and if. Okay, and we're going to start command line stuff too. And the program is never at fault since it just, true, programmer error. That's why I said if you program it poorly, right? So it's my fault. So the adjective kind of determines who's the one screwing yourself over. Okay, so if we do this too, namespace Minecraft, namespace, command line. This is gonna be like, I know most of you guys have probably played Minecraft, but if you haven't, like, you can pull up chat and everything. This is sort of gonna be that. And maybe I shouldn't call it command line because you can chat in it stuff too. I don't know. I might separate those concepts out in the future. For now, this is good. But we'll just have like a void update for now, which takes in a float delta time. DT, and we might take in a registry too. I don't think we need to, but who knows. Why to use old header guards? Because I think like Linux doesn't like this. My friend does C++ on Linux and he always gets like warnings whenever I use Pragma once because I'm pretty sure this is like a Visual Studio. Technically it's not supported, right? So Pragma, yeah, every compiler does do it, but if you look at like GCC, or right, GCC or G++, it's not technically supported. Like it is, but it's not. I don't know. It's weird once you get to like GNU stuff. And Pragmas are all differently supported for like different compilers, right? So GCC supports several types of Pragmas, blah, 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 blah. But basically Pragma isn't well defined across different compilers. So you could have like a Pragma directive that one compiler supports, but another compiler doesn't. And I've just taken to doing this because I'm like, okay, this will be supported by all compilers. So you can write it, it works, but this is definitely supported by everything. So I just err on the side of caution. SE Woods, your parents say that you never do anything wrong. So for me, it's always the program's fault. Okay, we'll go with that for now, SE Woods, but we'll go for that. You haven't done anything wrong so far, so I can't argue with them. Okay. So yeah. Okay. Anyways, though, with that aside, let's go ahead and write this. So, and I'm not quite sure on that too. For all you C++ developers out there, because I know different compilers support different pragmas and stuff. Like, how do you deal with that type of stuff? Because it's like you want to write your code so that's as portable as possible and you don't have to change it too much. But at the same time, it's like you can just do hash if defs to target different compilers and stuff. So it's like, where do you draw that line is kind of something. See there for Pragma support. Thank you. So I'll check that out in a minute. Gameplay command line. Let me just click on that real quick. Yeah, so Pragma once, yeah, so it's non-standard, but widely supported. Yeah. So non-standard. Oh, scroll down. Okay. I'm missing something. Using Pragma once allows a C preprocessor. Caveats. Identifying the same file on a system is not a trivial task. Symbolic links are especially hard. Compilers may use a heuristic. Pragma once can do the wrong thing if the same file is intentionally copied into several parts of a project. Whereas include guards would still protect them from double definitions. Pragma once may or may not treat them. Okay, so this is definitely something that's important to keep in mind too. Allows dependent code to recognize and respond to slight differences in semantics. Okay, yeah. I think this might be the original reason I started using it and I've just kind of forgotten, but yeah. At the bottom. Oh, okay, here. So portability, supported. Yeah. basically everything supports it, but I think this is the reason that I originally started doing it, because different compilers can implement it different ways, and they're not going to implement it weird. Like, you can probably count on this being fine for almost all things, but like I said, it's not standard, so I avoid it. That's basically my only reason. And if you use like a GNU compiler, it'll give you a warning. So I was like, okay, whatever. If somebody's compiling, I don't want to have warnings for them. So, well, hash if not defined will work 100% of the time in hash. Yeah, so that's sort of my point too, is like, it works 99% of the time. Just add in the macro guard, and it's like, it doesn't take much time to do this. So, you know, and I think all modern compilers add in like optimization supports for this, because it used to be where like if you include a file, it includes the whole file. But now they sort of check for a macro guard or a pragma once, and then they sort of halt pre-processing if they've already seen this file before. So anyways, that's a huge aside. But yeah, if pragma once doesn't work for a person, update your freaking compiler. Yeah, but you got programming gurus like Sean Barrett, right? Who everyone uses his libraries, STB. But I have a feeling his compiler wouldn't support pragma, because he still uses like Visual Studio 1999 or something crazy like that. So, you know, I don't know. I saw a stream with him one time from a couple years ago, and I was like, what is this guy using? Like, he's using Windows 7 or Windows 5 or something weird. I don't know. Anyways, if we go into here, first thing I want to do for this command line is, let's see what I'm doing for my debug stats too, because I might need to add in something. So let's close all this stuff out. And let's go into here and here. Okay. So it looks like I'm saying if we have this font, I'll use the same font. Then we draw this. Okay, so it looks like I'm going to sort of follow this pattern. We'll include render fonts. That's good. We'll also include render style and render. Okay, so we need all that stuff. Also, you're planning on switching to C++ 20 modules, so won't have that issue. Still waiting for better tooling support, though, specifically ReSharper support. Did you just say Windows 5? Yeah. Let me find that video real quick, okay? Just for your guys' edification, because Sean Barrett, I think it was like Jonathan Blow. He had a video with him or something. Well, yeah, he did, but I also watched a video with Sean Barrett specifically. Sean Barrett, YouTube. Let's see. Nope, I'm spelling his name wrong. Let's see. Okay, so it looks like he is using... Wait, no, yeah, look at that. Okay. Look at that GUI. That is not Windows 7. That's like freaking DOS or something, okay? So I have no idea what version of Windows this is, but it's not anything recent. So yeah, I have no idea. And this is what the guy looks like too. He's getting pretty old, so yeah. Okay, anyways, with that aside, we'll continue again. And you, Tree, you still prefer C++ 17. StudSpan is really handy. I've never used StudSpan. I'll have to look at that now when I get a chance. I don't have it included, so I wouldn't know. But yeah. C++ only has freaking concepts, yeah. GLM has already switched to C++ 22, because I noticed when I compile, they have a bunch of warnings. It's like, oh, C++ 20 does not, you don't support concepts yet, blah, blah, blah. So, yeah. Anyways, though, we want to draw like a gray box. Let's see. I'm going to use this same color. I need to add all these to like parameterize all this stuff and add it to a configuration or something so that I can change all this up in the future. For now, though, I don't care. And then we're going to draw a filled square. And I want to draw this filled square at the bottom of the screen. So we'll say like GLM vec2. I think the viewport is like -6 to -6, -3 to +3. So we'll do like minus 4.3f. I don't know. I'll see where that goes. I think it actually might be the opposite. So minus 2.9f. And what else? Minus 3? I don't know. 4? I'll try that. See what happens. Remove that. And let's see where that ends up. And then I also need to add in drawing support for that. So let's go into the world. Yeah, did you build your own computer? Concepts are the best addition since C++11. Yeah, they look pretty cool. I'm gonna have to start, I don't know, I still haven't looked into templates too much too though, and templates are pretty cool too. Okay, anyways though, let's see, where am I drawing the debug stats? Because that's important to know. Yeah, where am I drawing those? What the heck? Okay, yeah, debug stats there. But where am I actually calling this function? Render. Oh, I think I'm calling this from like my key handler or something. Key handler. Yeah. Okay, yeah, here we go. So if show debug stats. Okay, cool. So we'll do something similar in here. So we'll have like static bool show command line, I guess is what we'll call it for now. And then we'll say if show command line. Debug, or actually like command line render. Okay, cool. And this will sort of make you lose your focus and everything on your window. So we'll say include core gameplay command line. There we go. That's good. Okay. So we got that. Oh, I think I called it update. We'll call it the same thing. That's good. Okay, so then if we go back into here, now if we, well, actually I have to first make it so that we can actually turn it on and stuff too. So we'll add that in a minute. The physics is still pretty buggy in this too. Sometimes you fall through the world, so I have to fix that. That's just an aside though too. Okay, so if we're gonna say if key bindings key begin press key bind show command line. I guess I'll just call this show chat. So we'll do that. Or key bindings key begin press key bind show command line. Okay, so if we get either of those, then we'll say show command line equals true. And then if escape is pressed, then we want to kind of get out of there. So we'll say if key bindings, which escape is kind of bound to this exit key, but I'll change that up. So we'll say if key bindings, actually I'll just do like, I don't know. Yeah, key bindings, key begin press, key bind escape. Okay. And this key bindings class is just sort of like an abstraction around key presses so that I can sort of index things directly. So we'll have show chat, show command line, and escape. And then if I go into keybindings.cpp, we can set this stuff up manually here for now, and then eventually we'll load it in from a configuration. So we'll say keybind show command line equals glfw command or key // Okay, we'll just do that. And then bindings keybind show chat is, I think it's like T in Minecraft. I might be wrong on that. glfw key T. And then bindings keybind escape is just going to be bound to escape. Okay, cool. So we got all that stuff, and then that should be fine. And we'll say show command line equals false. Okay, cool. So that should all be set up now. We can sort of turn that on and off. SE Woods, I understand my question, but could be understood in different ways. But I was actually wondering if you custom built your computer. You might have answered. Oh, okay. Yeah, I did. When I first read that, SE Woods, I thought you were like, oh, did you build your own computer like JDH or something? But gamers always custom build. I did build my own computer though. This is my first computer build ever too. So it's like, there's still things that I probably will change with my next build. But, and I did some things pretty bad on the first go around. I bought a really bad liquid cooler that broke within like a year or two. And so maybe it was like a year. It was RGB and stuff, and it wasn't very quality. And I had to replace that ASAP because my CPU was at like 80 degrees Celsius, going up to like 90 for just having like nothing open. And I was like, this isn't good. So I had to get that fixed and everything. But this new liquid, or I'm using a liquid cooler still, not RGB, but it's much more heavy duty, and it's been working pretty good. But yeah. And meanwhile, I'm here annoyed that my hardline tubes aren't perfectly straight. are the hardline tubes for the liquid cooler. See, like I'm not that well versed in computer stuff, like hardware stuff, but mine aren't straight either because I have a pretty small case. I saw my friend's case, which is this really freaking awesome thing. I think I have it saved over here. Do I? No. If I don't, I need it saved because I want to get it. It's like a Corsair. Yeah, okay, here we go. It's this boy. And, oh, it's a nice case. Okay, it's just a really nice case, and I want it because this front part is like a mesh that you can pull off. So you can just pull the mesh off to clean out your fans and stuff. And it goes like over the fans. That way the dust buildup is on the mesh and not inside the actual computer. They have the same thing up top here, and it just has a ton of room. And my current case is small, so I just want to change that up and everything. And it's a custom loop. Okay. Of course, meanwhile I'm here on a laptop. You'll get there, okay? I was on a laptop too for like till almost the end of college when I finally saved up enough money. But being a programmer pays off. You get cool toys eventually. This is mine. Let's check it out. Oh, dang. Wow. Yeah, so you've got like actual, like these are rigid. This looks super sick though. Dang, I can't even tell. Like, is this the GPU and stuff? Or no, wait. Okay, so you got your fans up here, and then I can see that's the motherboard and that's your RAM. And I'm guessing the CPU's back there. And yeah, I think this is the GPU. But yeah, okay. That is sick though. I really like that. Mine is not looking good, so I will not show it for a while. I need to clean it up a little bit and stuff, but yeah. And yeah, college was the reason you bought a laptop over a custom build desktop. Yep, I did the same thing, and it is nice to have a laptop for college because it's a lot easier to carry around and stuff. And I was stupid and bought a gaming laptop. I mean, I guess that's not stupid, but like I figured, oh, it's going to be the same performance as like a gaming PC and stuff. But what they don't tell you is that the GPUs and the gaming laptops are like not good. It's not the same as a GPU in like an actual lap or actual PC. So I feel like that's a bit of misleading sales tactics there, but yeah. And as he would, I used one of the ice bags that comes with the freezer to cool my laptop playing a game. Dang. It's not a gaming PC. But then I saw condense under the glass plate caused by the ice, so finally understood that the water condense might occur inside the laptop. Ooh, that's got to be scary. I would have been freaking out if I saw that too, but hey, if it works, right? And you have a laptop sitting at 50 degrees Celsius, and I'm not doing anything. That's actually not that bad. I think 50 is like a pretty good base rate. Yeah, like I said, when my liquid cooler broke, my PC was sitting at like 80 degrees Celsius doing nothing, so not good. But let's go back into here. I think we should be good now. Like we should be able to show the command line little thing. And I'll sort of add more. I need to add like actual GUI system before I can sort of work with this very well. But if I hit slash, we should see something pop up, but we're not. If I hit T slash, nope. I might just be drawing it in a bad place. Let's see. So this is where I have this one drawn. I'm going to copy that and go into this guy, copy it here. We'll see if we get it shown. I'll put a breakpoint in there too, just to make sure that we're actually hitting that. No more ice cooling. In case you're wondering, it's a 5950X with 32 gigabytes of RAM and a 3090. Dang, dude. That is nice. I've got RTX 2080, and then the CPU is just like an Intel i7. It's an overclocked CPU, but I don't have it overclocked because I don't want to mess with that stuff yet. But yeah, if I hit slash, okay, so we go into here if I hit slash. So we're hitting that breakpoint. Whoa. The physics broke completely. At least we got the command line thing drawn up there, but that was not good. Okay, so let's change this Y coordinate real quickly too. To like minus 1.35. We'll see how that looks. Yeah, that is a beast of a computer though. I'm sure it provides very well for you too, so that's good to know. Okay, there we go. Yeah, so we got a little command line thing down there. but, oh, and if I hit escape, well, first I have to rebind the exit key. We'll say exit is GLFW F12 for now. Whoops, I actually pressed F12. That's not what I meant to do. F12. GLFW key F12. I'll eventually add key combos to this so that you can do like key combinations and everything. But for now, this is how it'll be. And the CPU can pull 200 watts. Dang. Okay, so that's expensive too. I did notice my electric bill started going up once I got a PC running all the time and everything. Not much, but it does add. So planning on upgrading at the end of 2022 when Zen 4 and RTX 4000 are released. Now, my question with RTX and everything too. My question with RTX and everything too is like, I've heard that the RTX 3080, it's either that or the 2080, is like pretty much on par with the GTX 1080 or something, like the newest version of the GTX. But the GTX is a lot cheaper. And the reason for that, I guess, is because the ray tracing is sort of like a different format and everything. So it's like, it's still sort of the same processing power, but it just doesn't do ray tracing as well. And I was wondering if that's true or not. But yeah, I am curious about that too, because it's like, if you're getting the same performance, is it worth it to go for the RTX? I do like my RTX and everything too, and it's never had a problem, so not complaining, just wondering. Okay, cool. So we got our command line down there too. If we hit T, pops up, and if I hit escape, it gets out of there. I will eventually bump that up a little bit because we'll have to probably move it so that the GUI can be down there and everything too. But I don't really want to do too much more with this right now, just because I need to like set up, and that's kind of weird too, I just know that, because I just want to set up the proper GUI system and everything too, like that. Okay, seems that the 3060 Ti, I can't read that, that might be 3080, is faster than 1080 Ti from a quick Google search. Okay, so yeah, that's what I heard something about that. I can't remember where I heard it from, so it could be definitely not true or anything, but yeah. I think I'm probably gonna end the stream here though, guys, because we've gotten to a pretty good point. Ray tracing, or raycasting, not ray tracing, is working. We can see which block we're hitting, and we can get exactly the point that we hit on that block, which is awesome. We can run around the world. We've got a little command line thing pop up. We can pop up our draw calls and everything. This is like really starting to look like Minecraft, and we're getting close. Once I re-implement the render for the meshing and everything, for meshing different things, we should be able to break blocks easily and add blocks. And I plan on using the command line to play around with like different block types before we actually get like a inventory system and all that type of stuff up and running. So we will be using that. But I'll probably end it off here though. And just to give you an idea, I will check out that YouTube video after this too. Thank you. And SE Woods, you're glad you came with the graphics card, because when you bought it, did not know it, use it for graphics farming. Yeah. The built-in like CPU graphics cards are usually pretty crappy, but they still work. Like I started learning on a really crappy computer that was made in like probably 2004, 2005. Yeah, it was bad. But my point is, when you're learning programming, and especially game programming, you can start with anything. And especially if you're making more simple things like this that don't require intensive GPU processing power, the integrated graphics cards can do pretty good. So yeah, it's the 3060. Okay, holding its own against the 1080 Ti. So new mid-tier versus old high-tier. Yeah, but the price difference is still pretty big, maybe? I don't know. I'll have to check that stuff out later. But anyways, guys, thank you for watching. I am really glad you were able to make it. Like I said, stay tuned for a couple weeks from now. I'll probably have like a couple of stream weeks. 8 o'clock a.m. is probably going to be closer to the actual time I'm going to be streaming from now on, Central Standard Time. So, yep. But anyways, thank you for watching, and I'll see you guys next week, hopefully. I have to figure out how to close that. Okay. See you guys.